Okay, I just had a false start with this recording, but I think we're squared away now. Please feel free to count how many times I say in this video, whatever it takes to help you focus and watch the video all the way through. This video really needs to be watched with the accompanying video, which is a whopping 50 minutes, because I go through absolutely everything in this video except for some of the content explanation, which you'll want to pick up from this video. So hopefully this video won't be too long because the bulk of the demonstration is in the other video, which I hope that you check out. So this is activity 1.3.3, which is constraining sketches in Fusion 360. So what are constraints? We talk about constraints, and we've talked about them this year when we've done the design process. When you're creating a design or solving a problem, you need to know the criteria and the constraints, okay? And your constraints are the limitations on it. It has to fit in this, amount of space, or it has to be, you have to use just these kind of materials. So when we're talking about constraints in Fusion, what we're talking about are limitations on a sketch that prevent it from becoming distorted when changes are made to other parts of the design. You're essentially saying this component of the sketch. I want to be careful about using those words because component actually means something different in Fusion when we start doing assemblies. So, but you've got like segments and angles and curves and pieces of your sketch, and you want to make sure that you restrict what those can do or how they have to be like in the sketch. Okay, I was probably messed up that definition a bit. So there are two types of constraints. The first type of constraint are dimensional constraints. That is specifying the dimensions of a sketch, and you've been doing this all along. So you create a sketch and you want the length to be 3 inches and the height is 5 inches. And so you actually can go in and you can dimension it. And that was important with the luggage tags, that you knew what the dimensions were so that you did not send something to the printer that was super huge. Oh, Vasya wants to join our lesson. Say hello. I've got 2 cats that, well, I have 3. 2 of them like to make appearances in these videos because they can't stand for me to be doing something that they're not in the middle of. Yep, you're gonna say hello to everybody? Yeah, okay. Moving on. You've got dimensional constraints, and then what this lesson focuses on is geometric constraints, and that's specifying how parts of the sketch are related to each other. And this involves quite a bit of geometry. So those of you that are in Algebra 2 or higher, seriously, go. Just okay. I love you, but go. Those of you that are in Algebra 2 or higher, you've completed your entire study of geometry. So you're going to have a bit of an advantage just in terms of the vocabulary and knowing what that vocabulary means in the sketch. Those of you that are currently in geometry or you're in Algebra 1, this really will help you as you get to different concepts in geometry. It's going to give you an intuitive sense of how these concepts work because you're going to be manipulating them within Fusion. So it specifies how they're related to each other. So your constraints can be found under the constraints panel, and that's just a screenshot of the constraints panel. We have looked at this a little bit. I've done a couple of sketches already where I have applied a constraint. There was one that we did where we had to put a square, a square centered on the origin, and we used a rectangle tool, but instead of dimensioning the 2 sides, I constrained the 2 sides to be equal to each other and then only dimensioned 1, which was another way of getting there. There are actually 12 types of geometric constraints in Fusion, and in this activity we're going to explore the different types of constraints, how they work and how they affect the behavior of the sketch. So there they all are, and I am going to write on the screen at this point to give you some of the background content. So the first kind of constraint, and that's this one right. This is why you're not invited to video time. Is this type, with the ones that have the symbol up here, I'll point out when we get to them. The ones that aren't, I did try to screen grab it from Fusion, but whenever I clicked on the snip and sketch, it undid like the menu option that I had. So I wasn't able to show them. But vertical and horizontal constraints are this symbol right here. And that basically just constrains a line to be either vertical or horizontal. Now, Inventor, vertical is the up and down and horizontal is side to side. Sometimes people get those confused. So in Inventor had separate constraints for that. They had a vertical constraint and a horizontal constraint. Fusion lumps them both together, which I don't really like, but they assume that if your line is almost vertical, that you're going to want the vertical constraint. And if it's almost horizontal, what it's going to do with a line that looks like that, I honestly don't know. You can check it out, try to do it. But if you've got a line that you need it to be horizontal or vertical, you would use that kind of constraint. Second kind of constraint is a coincident constraint, and this is the symbol for that. In Fusion, and if you watch the other video, you can hover over the different constraints and they will tell you what they do, like that little menu drops down. So a coincident constraint, where I usually use it, is you constrain like 2 points on top of each other. And in the design that you're going to be doing for this activity, you've got the origin, which of course is the 0.00, and then you have like a line. Okay, and then you've got the midpoint of the line, and the midpoint of the line is not at the origin. And what you can do with that particular kind of constraint is you click that, you click the origin, and then click the other point, and it constrains the midpoint of the line to be on the origin. The next kind is a tangent constraint, and the symbol for that is this. And this is where we get into your geometry concept. So for those of you that are in geometry, you probably haven't done tangent lines yet, but a tangent line is a line, so that's supposed to be a circle. A tangent line just touches the circle at one point. It doesn't actually go into the circle. So this line would intersect the circle and it would give you a chord. And there's all kinds of theorems that govern like the length of the chords and if you made like an angle with your chord and that sort of thing. But a tangent line is just touches the circle. And so you can make circles tangent. You can also do stuff like this if you had a I don't think we've done the pair cam yet, but we will do the pair cam. And I can't win. Like the cats just keep coming back. I need to shut them out of the room. But we've got like these circles. We've got like a little circle and a big circle. And then we draw these lines, okay? And the lines are intended to form like a pear shape. And they're not necessarily tangent. And what you can do is click on the circles and click on those lines, and it will automatically make them tangent. You can also do something like this if you have an arc and then you have a line, and see how it's got kind of a corner right there. Like it kind of abruptly goes from the arc and then into the straight line. You can use a tangent constraint to make that a smooth curve. For those of you that are in calculus, you know that the like whether or not you have like that little corner can make something differentiable or not differentiable. So you don't want those corners. And so you can use a tangent constraint there and it will make it a smooth curve. Next one is an equal constraint. And that's pretty straightforward. That just takes two segments or two circles, two feet, like two elements of your sketch, and makes them exactly the same size. It doesn't say what the dimension has to be. It just says that like the dimension, whatever it is going to be the same. I think the next ones are fairly obvious. So that's the equal constraint. Parallel and perpendicular, that will force two lines to be parallel, even if they're not parallel the way that you drew them. And then perpendicular will force them to be perpendicular, even if you did not draw them as perpendicular. The next one here with the lock, this is fix or unfix. And that fixes a particular point on your coordinate plane so that it cannot be moved. So that will allow you to use that point as a reference point. And then the little triangle is the symbol for midpoint, and that constrains something to be happening at a midpoint. So for example, if you have a line and you got your midpoint and you need to have some other segment coming in and it needs to be at the midpoint. So I'm going to use some geometry symbols. Those of you that aren't in geometry, those symbols are to indicate congruence. Okay, so if you constrain this to be at the midpoint, and then you go and change the length of that segment, it will move this segment so that it stays at the midpoint. So if you, like if this were 10 inches long, okay, let's just say that's 10. And so this would be 5 and this would be 5. So if you dimension it with a dimensional constraint and then you change the 10 to a 12, there's no real predicting where this point is going to go. Like it might stay at like 5 and then you'll have 7 on the other side and it's no longer in the middle. But if you do a midpoint constraint and then you change the 10 to a 12, it's going to make sure that this stays in the middle no matter what and it doesn't change. Now we like lose the icons up there. So concentric, I think we've talked about this word before because we did it when we did the accuracy and precision activity. Concentric, just so to break it down, the prefix con means with, and then you have centric. And so you can think with center, okay, it means with the same center. And so if you've got like a circle, and then you've got this like other circle, but that's not what, that's so bad. Okay. You've got a circle and then you have like some other circle and they're not concentric, but you want them to be concentric. You can use that constraint. And that way, if you move one of the circles, the other circle will move with it and it will move with it in such a way that they stay like centered one within the other. And so that's what a concentric constraint does. Collinear. This word is used in geometry. Collinear means on the same line. Okay, so the prefix co often means with or together, like think of cooperation. Okay, like together, like cooperate together. And so like linear means like on the same line or with like together on the same line. So that can be used in a lot of different ways. I know one of the ways that I use that is if I have some kind of like prism and I want to cut something into it, like I want to do an extrude cut. It can be really hard to get your lines to actually match up. And so what I will do sometimes is I'll draw a rectangle inside and then I will use that collinear constraint and I'll click the edge and then I'll click the edge of this and it will make them on the same line. It will basically move this line so that it's on top of this one. And I'll do the same here and the same here so that I can be 100% sure that the figure I want is like right, like it lines up perfectly, which is really, really hard to draw. But if you put that constraint on it, then Fusion will do it for you and say, okay, make sure that these are exactly the same. We're going to use a collinear constraint in this particular lesson to line up two pieces of a figure. So you might have a line here and a line here, and they're clearly not on the same line. And so you can click the collinear constraint and you can line these up so that they will be right next to each other and they'll move together. Symmetric is kind of what it sounds like. It forces two things to be symmetrical. So in this example here, if I drew another rectangle, I could click the first rectangle and the second rectangle and then force them to be symmetric. Now, in order to use that, you need to have some kind of line to use as a mirror line. And so what you would probably do is you would draw like an extra line through the middle and say, okay, I want these two figures to be symmetric over that line. And then the curvature constraint, I've never used that. In the video, I hovered over it to see what it did. And I forget what it does. It like forces a curve, like forces a point to be on a curve, but I think Coincident will do that as well. Now, like I'm recording it, I'm like, I don't remember, and I can't click out of this video to go and find it, but I have not ever used the curvature constraint. So that there's like kind of our rundown on that. Let's erase this stuff. Okay, here's the big deliverable for this particular lesson. So if you're wanting to know what do I have to do with this, is a screenshot of your properly constrained sketch. So we're going to go through actually 3 activities, and it's the 3rd activity that you are going to really take your time on and make sure that you get all of the pieces of that sketch constrained the way you're told to, and then you're going to screenshot it for me with all the constraints and stuff in place. And please see the 50-minute video in the Wakelet for an overview of the entire activity. It's strong but comprehensive, long but comprehensive. And comprehensive just means it's very detailed and it's going to give you all the information you need, because I literally do all the things that are in this video that say do this and then do this and then do this. Like I will model them. So what you can do if you've got Fusion access at home is play that video on a tablet or on your phone or something, and then have Fusion up on your laptop, and it will literally walk you through the entire activity, including all of my little foibles and things that I get wrong. You can also count my ums if you want to, just like you might be doing in this video. Knock yourselves out, kids. Okay, activity 1. I adapted this from the PLCW. I think the activity could be a lot more efficient. I made it more efficient than it was last year. And of course, next year, I'll make it more efficient than it is this year, unless I decide to keep all these videos. But here are the goals of the first activity. It's to observe automatic constraints after they have been made. So Fusion actually tries to read your mind, and it tries to put automatic constraints on stuff. In other words, it will look at your figure and it'll say, it looks like Sally is trying to make these parallel. We'll just snap them parallel and put a parallel constraint on them, even though Sally hasn't told Fusion to do it. Most of the time, Fusion is pretty good with this, but every once in a while, Fusion will put an unwanted constraint on something. So the second goal of this activity is to practice removing unwanted constraints. You have to be able to observe that a constraint has been put into place and then know how to get rid of it if you don't want it. And if you're not really intentional, like sometimes Fusion will put these constraints onto a sketch and then you'll go to dimension something and it'll give you this weird error. It'll say, this will overly constrain the sketch. And it's because Fusion has put a constraint on it that you might not even be aware that Fusion has done it. And then observe how changes affect an unconstrained sketch. So we're going to remove all the constraints except the coincident constraints at the corners of a sketch, and then observe what that means you can do with that sketch in terms of moving it around. So quickly create the sketch below using the line tool. And you're going to create something that looks like that. You're not going to put any measurements on it. It just sort of needs to look like that. So you're not going to pour over this. Grab the line tool and just like click, go up, like basically the general shape of what that is. Okay. And then we're going to talk about in class. I'll do it in class, and note the automatic constraints. Note the things that Fusion assumed that you wanted. And then we'll remove the automatic constraints. You remove them by selecting the constraint by left clicking. It's going to bold the constraint. And if the constraint is like paired with another piece, it's going to bold both of them. So if you have a parallel constraint, both of the lines are going to have a symbol next to them that says, hey, these are parallel, and it's going to bold both of them. Then right click and choose delete, and it will remove that constraint. And then choose any side or vertex and drag it around the screen, and just note how the unconstrained sketch behaves. So we will do that together as a class. And of course, I do it all in that video. So you can watch the video, you can fast forward to different parts of it, because I think I go through all the constraints in the other video as well. So. All right, so that's activity 1. If you're trying to do this at home, I strongly suggest you pause the video here and just kind of work through that, like pull up the other video and work through that. Activity 2. What are the goals of activity 2? Observe Fusion as it creates the automatic constraints. So you can actually, if you are intentional enough and you're slow enough, you can observe Fusion as it's putting the constraints on the sketch. And so you can avoid them if you don't want them. You can, like, Fusion will, it's not like trying to do it on the DL or anything. Learn how to avoid unwanted automatic constraints. So we're going to try to avoid them. Like if you're like, whoa, I don't want those parallel, and Fusion is about to make them parallel. And then observe how changes affect a constrained sketch, as opposed to activity 1, where pretty much everything is going to be removed except the coincident constraints. This one, we're going to leave the automatic constraints in place and just observe how when we click and drag the different pieces of the sketch, that you can see those constraints in action. It definitely does not behave the same way the first one did. So the sketch is going to, well, yeah. Oh, there it is. It's kind of like underneath my face. Well, that's helpful. Work slowly and notice how Fusion tells you when it's going to apply a constraint. And again, if you're doing this in class, like I'll work through it with you and we'll look at like, oh, look, see this like in blue, it's going to apply a constraint here. And then click and drag the various sides and vertices to see how the sketch behaves. So this one looks, it's a 10-sided concave polygon and it looks something like this. Okay, it's like something like that. And just, again, you're not measuring anything. It doesn't have to look perfect. Like the one there looks like it's perfectly centered around the y-axis, but I don't think, yeah, it doesn't have to be in order to observe this. And so pause the video and kind of work through activity 2. Activity 3. Here are the goals. This is the big one. This is the one that's, we're on slide 6 of 18. So the whole rest of this presentation is going to be activity 3, but a lot of it is going to be done. It's like done in the other video. So I don't think that this video is going to be too much longer. Oh, that's annoying. I don't know why I put that on there. So this one is, the goal is to use both automatic and manual constraints. So this time we are going to draw the same figure that we drew for activity 2, but we're really going to pay attention to it, and we're going to force Fusion to kind of put certain constraints on there. We're going to predict the behavior of a sketch with given constraints. So once you know how a sketch is constrained, what can you know about how that sketch is going to behave, and then practice using the different constraints available in Fusion 360. That's the manual constraints. So you don't just have to rely on Fusion to put these constraints on. You can manually put constraints on a sketch and tell Fusion, this is how I want this sketch to behave. This activity has a deliverable. Follow along closely and reference the video and PowerPoint online if you fall behind or need to review. So if you do lose some ground on this, and you know how it is when we do big whole class Fusion activities, the class ends up being spread way far apart. So just know that you've got some resources if you end up falling behind. For this activity, we will be redoing the sketch from the previous activity, except with very specific requirements. So not just whatever Fusion decided to put on here, but we'll make sure that it's going to be very specific. You'll see. Open up a new sketch and set your units to millimeters. Please set them to millimeters. Then follow along with the steps. I will read them and then demonstrate them in Fusion. Of course, not in this video. You're going to have to hodgepodge and combine this video with the demo video to get all of that, but you can still do it. And yeah, do not work ahead and then expect me to fix errors for you. That's more for everybody who's doing it in class. If you're reading ahead, you're like, I can do all these steps, and then something goes wonky and you weren't following the directions, you weren't listening to everything I was saying, which I know I'm wordy and you guys tune me out about half the time. but sometimes I have these important things. So if you are launching ahead and then you realize that something is not working or behaving the way you'd like it to, that's on you because you went ahead. So here are the steps for sketching, and for the purposes of this video, I am going to go through these very quickly. So in class, we will go through these much slower. So you're going to place the line along the x-axis, allow a horizontal constraint. You're going to make the second line coincident with line 1 on the left end and perpendicular to it. Let me just explain what that means. So when you're drawing with the line tool and you kind of let up on the mouse and you change directions, one of the constraints that's put on there is that you're assuming that you want the end point of the first line to be on the same spot as the beginning point or end point of like the second line. And so there's a coincident constraint there. We almost never pay any attention to that because it seems like an obvious kind of thing for Fusion to do. So you're going to make the line 2 coincident with line 1 on the left endpoint and perpendicular to it. So you're going to be looking for that constraint there. Make line 3 perpendicular to line 2 and heading to the right. That just means I want the line going that way and not like that way. Okay, we don't want it. We want it heading to the right so we can make our sketch. Make a line 4 diagonal and heading upward to the right. So something like this. It doesn't specify the angle. Try to avoid any kind of automatic constraint that might pop up there. Make a line 5 heading upwards and have a perpendicular constraint with line 3. And so that's like this. Okay, going upward, and then you should see a symbol pop up that shows that this line is perpendicular to line 3, even though they're not touching each other. And then make the 6th line heading right, but intentionally avoid having Fusion, what does that say? Apply the horizontal constraint. So you're gonna make like line 6, but make it off the horizontal enough so that Fusion doesn't put the horizontal constraint. We are going to constrain that later to be horizontal, but this is that practice on avoiding a constraint that you don't want. If you don't want that horizontal and you don't want Fusion making it horizontal, then you've got to draw it in a way that's going to be definitely not horizontal. And then complete the sketch as follows. You're going to make line 7 heading down parallel to line 5, make line 8 perpendicular to line 4, make line 9 parallel to line 3, but not on the same level as line 3. So that's a collinear constraint. We're going to try to avoid the collinear constraint so that we can apply it ourselves. And then, yeah, we'll constrain this later, and then use line 10 to connect line 9 with the right end of line 1. So the sketch should shade blue to indicate that it's closed. So this is a much more intentional drawing of a sketch where you're really looking at what Fusion is trying to do. You're going to make it do certain things. We're trying to avoid certain things so that we can practice with those constraints. Mine looks something like that. Okay, so we've got here, this is on the x-axis, perpendicular at an angle, perpendicular to line 3. So then 6 is off, and then you're going to bring line 7. Make sure line 7 is constrained to be parallel to 5. Line 8 just goes off at a diagonal, but we're not specifying the angle. Line 9 should be parallel to line 3, but not lined up with it. So if I trace line 9 going across, like it's not lined up. And then wherever your line 9 ends, just connect that back to the beginning of line 1 to close your sketch. It won't look exactly like this, but as long as you have the right constraints in place, like it will look something like this. Like if your sketch looks like this, okay, like you did it wrong. It doesn't look like that. Okay, so now we're going to add the following manual constraints. So we are going to put constraints onto this particular sketch. Note, in general, Fusion will constrain the second object you select to the first object you select. Keep this in mind when choosing which object to select first. Sometimes it doesn't matter. And if one of the pieces is already fixed in place because of how it's related to other elements of the sketch, like this won't hold true. That's why I said in general, in general. So, and I think in the video, if you watch the video, I did like one of these constraints and I like did it one way where I clicked one first and then the other, and then deleted the constraint and did it the other way, just so you can see. So, you know, it is worth checking that out. So we're going to make lines 2 and 10 parallel. So those are the far left and the far right end. So I think mine looked like that. That was line 2, and then line 10 was over here. So you're going to constrain those to be parallel. And I think this one is going to be constrained to be vertical because the original line 1 had a horizontal constraint on it, and this was already constrained to be perpendicular. So no matter what order you fix them, like 2 is already stuck. So 10 is gonna have to move in order to be constrained to 2. You're not gonna get 2 tilted so that it looks like 10, because that would violate a constraint that's already on 2. Make line 6 parallel to the x-axis. So that was that top part up here that we intentionally did on the diagonal, okay, to avoid the horizontal constraint, but now we're going to put a parallel constraint on that. And if your first line is constrained to be horizontal, then if you constrain this to be parallel to line 1, then you'll have it parallel to the x-axis. Make lines 5 and 7 the same length. So those are the 2 vertical pieces here that might not be the same length. So you're going to constrain those to be the same length. And that might be a good opportunity to just try clicking in the different order. So like click it and then delete the constraint and then click it the other way, like whether you click 5 first and then 7, or 7 and then 5. Just to see how fusion behaves. And then make lines 3 and 9 align with each other. And that's going to be a collinear constraint that you put on lines 3 and 9 to make sure that those two, because we intentionally drew them so that they were off from each other. And so we want to get them lined up so that when you move like one and the other, like they'll move together. And now we're going to do some construction lines, which we need to do some of the other constraints. So a little bit of background. Construction lines are lines that are not part of the sketch, but are useful in creating the sketch, kind of like the axis of symmetry when you're sketching a parabola. So for all my Algebra 2 and higher people, you guys have all gotten to the point in Algebra 2 at this point where you have your parabola and then you have this line down the middle, which is called the axis of symmetry. And we make the axis of symmetry dashed because it's not actually part of the parabola, but it is useful in sketching the parabola because for every point that you have on one side of the axis of symmetry, there is a point on the other side the same distance away that pairs with it. And so that's like kind of what a construction line is. A construction line is not part of your actual sketch. It's not considered, it's not considered a construction line if we go back to our line conventions, but it is useful in drawing elements of the sketch. Construction lines appear as dashed on the sketch, and you can create construction lines by choosing that option from the palette on the right. And I have a little note there. Also note the option to hide constraints, which is behind my face. So this right here is your option for choosing your construction line. And so once you have your sketch palette open, you can click this, and basically anything you draw from that point on is going to be dashed. It's not considered part of your sketch. And so, and then make sure you turn it off. I think that's on a slide later. And then underneath my head, you have to take my word for it, there's in that same sketch palette, there's a little box that you can check or uncheck that says show constraints. For this activity, you obviously want it checked so that you can see the constraints, because that's the point of this lesson. But there are times when those constraints get really, really cluttery. Like there's so many symbols all over it. And so you might want to hide them so that they're not in the way. So it's just kind of one of those things, like file that away under stuff that you should know where they are. So we are going to draw a construction line connecting the midpoints of lines 6 and 7. Note that a triangle appears when you hover over your midpoint. So lines, I think I said 6 and 7, but I meant 1 and 6, and that's what's there. So 1 is the bottom line and 6 is the top line. And when you hover your cursor over the line, this little triangle, this little blue triangle will appear. So you kind of, and that is your midpoint symbol. So that's how you know that you're at the midpoint. So you're going to hover your cursor over that top line until the triangle appears, and then you're going to bring it down, and it's going to draw, we'll click it so you can draw a line, but it's going to draw a dashed line, and then bring it down to the bottom line and find the midpoint of the bottom line. And then what you should see is something like that. Like it should be a beautiful dashed line connecting those two midpoints. If your construction line isn't vertical, then add a vertical constraint to it. So depending on what constraints like Fusion put on your drawing, it might already be vertical, but if it's not, go and put a vertical constraint on it. And if you cannot tell, then put a vertical constraint on it. Those of you that are in geometry know that there are certain rules for what you can and cannot assume about a sketch. So you can't assume a line is vertical just because it looks vertical. Like if you can't tell, like put the constraint on there. Fix the midpoint of line 1 to the origin. So this was originally supposed to have been on the x-axis, and in the video, like I just kind of drew mine sort of near the x-axis. I struggled with this in the demo video. So if you watch the demo video, I actually had to pause the recording to figure it out, because every time I tried to put first I tried to do like fix, and that was poor phrasing on the part of PLTW, because it's not the fixed constraint, which is what it seems like what you want to do is use a coincident constraint. But every time I tried to do it, and I don't know how many times in the video like I did it before I stopped the recording and just gave myself a chance to figure it out. But it'll give you this thing that says this will over constrain the sketch, or like it just won't let you move it. So the PLTW curriculum says you may need to delete one of your existing constraints in order to make this work, which is ultimately what I had to do. So I had to delete some other constraints and then put the coincident constraint on it, and then it moved it. And then you want to use that fixed constraint to fix it in place. So you're going to use a coincident constraint and then a fixed constraint. But that could take you a little bit to do to get that lined up right. Draw a construction line from the midpoint of line 2 extending into the figure. Be sure to turn off the construction feature when finished. I often forget to do this. Like it's that little button that's over there that you click to get a construction line, and you need to click it again so that you're not in construction line mode anymore. And I don't even know how many times I have inadvertently done construction circles and everything else because I haven't turned it off. You can actually, like if you do that by accident, you can click on the feature or on the sketch element and then deselect it if you find that you end up doing it. But it's easier just to remember. So what you're going to do in this step is, this is line 2. You're going to hover over the midpoint of line 2, and you're going to do a construction point or construction line into the figure from the midpoint. Tangent and symmetry constraints. So the last couple of constraints. Draw a circle in the lower left of the figure. Align the center of the circle with the point at the juncture of lines 3 and 4, and then make the circle tangent to the construction line through the midpoint of line 2. Adjust the size of the circle so that it fits in the object. That's not necessary because we are going to dimension that circle later, but it does just make it a little bit easier to manage for aesthetic purposes. So you can click the edit and just kind of make the circle a little bit smaller if you've got it bulging out of the figure. So pretty much this is what you're going to do. You've got this, and then you've got this construction line right there. You're going to put a circle kind of like in that area and apply a vertical constraint to the center of the circle and that point right there. So mine is a little bit off center, and what that's going to do is it's going to line the circle up with that point vertically. So if you need your circle, your hole, whatever this ends up being, you need that lined up perfectly. A vertical constraint will do that. And then you're going to apply a tangent constraint between the circle and this dashed line there. Okay, and then again, adjust the size of the circle, not because you have to, but because it just makes it easier. It just makes it easier to get it to fit. You can just see things better. Then draw another circle on the other side of the figure in a similar place, and constrain the second circle to be symmetric to the first. And then this, in the video, because I was working through it and I kind of whined about it in the video, I actually do not like this way of completing this portion of the design. In the video, I eventually deleted that constraint when it didn't behave the way I wanted it to behave and redrew the right-hand circle using the mirror tool in the create panel. I just didn't like, when I got to the dimensioning part of it, I did not like how that second circle was behaving. I did get it to be symmetric by following by following what I was supposed to do, but I did not like it. So I eventually deleted that whole piece of it and redrew the circle using the mirror tool in the create panel. So that's an option too. If you guys get to the dimensioning part of this and it's really wonky, I can show you how to do that. And I think I do it in the video. I'm not sure. Maybe I did it when the video was paused, but I did change it. Adding your dimensional constraints. So by adding dimensional constraints after the geometric constraints, we reduce the number of elements that need dimensioning and we make it easier to make changes to our design. So you've got fewer things you need to get dimensioned because you've already dictated, like, these have to be parallel, these have to be equal, these have to, whatever. And so it can make it easier to make changes to your design later. Note that the order you apply dimensional constraints in may make a huge difference. If a dimension grossly distorts the sketch, then delete it and try a different one first. So sometimes you'll put a dimensional constraint on your sketch and your sketch will do this. Okay, which is not what you want. You don't want that you don't want. And so if that happens, click backwards, click your undo button, get rid of that dimension. You don't want to forget about the dimension, but dimension something else, like move on to a different dimension and then come back to that one, because sometimes it means like one line was like too short, and so when you expanded something, it had to like crisscross itself. But if you make that line longer first, then the second dimension won't do that to it. So just kind of bear that in mind. Here are your dimensional constraints. So there's what you need to do. You're going to make this 20 millimeters. This is 15. This is 15. And then the whole thing is 45. Remember to do the whole thing. You would click the top and then the bottom and then drag out. And then the diameter of the circle is 5. Notice that the dimension, pretty much this whole thing, you only need 1, 2, 3, 4, 5 dimensions. Oh, 600 across the bottom. 6 dimensions. So there's a lot you don't need to dimension. You don't need to dimension this side or this side or this side because of the constraints that are on there. You know that like segments 5 and 7 are equal, and you can actually see the equal constraint on there. So there's no need to dimension them both. And then those of you that know geometry, like you can kind of go further with this because you know like how a rectangle behaves, you know your parallel lines, supplementary angles, like same side interior angles, that kind of thing, where somebody that's not taking geometry or hasn't finished geometry yet doesn't necessarily know all the geometric relationships involved, and so they might like try to over constrain something. All right, you will likely find that when you start to add these dimensions, your sketch is not fully constrained. What that means, this means that some pieces are still allowed to move and change in ways that you don't want. And so when you start dimensioning, and this happens in the video, so if you want like a first-hand look at like what happens, because the video is it's very raw footage of Fusion, but it will start to move and change in ways that you don't expect or want it to change. And so what that means is that you have some kind of mobility in there that you don't want to have. So something is allowed to move in a way that you don't actually want it to move. In the video, I had to add another constraint. You may need to do so as well. And if you're wondering what constraint did she add, because my figure is a hot mess, watch the video and you will see me add it, add the constraint in. that to get it to behave the way that I want it to behave. All right, now there's a video to watch in PLTW. So open up PLTW, go to activity 1.3.3, scroll down until you find the video on design intent and watch this. I may have you take a quick quiz to determine if you watched it. At the time of this recording, I'm not sure. It just occurred to me. Maybe we'll do it. And then make some predictions. So what will happen if you make the base 125 millimeters instead of 100 millimeters? And then do it and find out. Go and edit the dimension, change the dimension to 125 from 100. How does that change the sketch? What will happen if you change the overall height from 45 to 60 and then to 80 millimeters? And so then go in and do it and find out if you are correct in your prediction. So it's, again, the whole goal of this is to learn about these constraints, learn how to manipulate them, and then develop a sense for how they affect the sketches and hopefully make you a better designer. And here's what you need to turn in. Make your overall height 100 millimeters. I did not do this in the video because I did not want anybody to be able to pause the video and screen grab mine and post that as their own. So that does not exist. Now, I did do it afterwards and post a screenshot of it with like my name, like scrawled all over it. You're going to do something similar. Take a screenshot, write your name on it in a way that will make it impossible for someone to steal your work from Teams. Okay, like it's got to be written in a way that, yeah, nobody's going to, like, they're not going to be able to go back and delete your stuff. But don't cover up any constraints or dimensions. I need to see them to give you credit. So you are being graded on whether or not you've got everything constrained the way it's supposed to be constrained and whether you have everything dimensioned the way it's supposed to be dimensioned. So you can't cover that stuff up. It is a big thing. It's like one assignment, but there's a lot in that assignment. There's a lot we just went over. And then I'll give you the option of either posting your screenshot in Teams and then tagging me or uploading it into Focus. You can submit it either way. And that's pretty much everything. So this was like another really long video, but it's a big lesson. Like constraints is a big thing. So you expect the lessons to be a little bit long. Hopefully this helps if you were absent or you need a refresher on some element of it. And yeah.